Everyone, welcome to our pre-calculus lesson 11. This lesson is a bit more on the properties of graph of a function. So we'll try to understand and analyze graph of a function a bit more. So we have first of all some graphs from real life situation, even and odd functions, increasing and decreasing or constant intervals, maxima and minima, then some practice. So yeah, we'll go step by step. So let's begin. These are some graphs from real life situation. Let me move myself here. And this is actually a question from our book also related. This is question number 39, page number 67 from the PDF book. Uh, of course, you have to use your kind of from everyday experience. You have to use the imagination, like how it will look like. Because in the book also, if you read this question, there is no enough data to exactly graph this. So look at this, what happens. Human growth, the graph of a human growth is like this. Like how your height increase, how our height increase. So when from our childhood, our height start increasing. Yeah. See, you can see our height start increasing and increasing and increasing. And at some point, people do not increase anymore. Okay, they just like it becomes kind of a straight line. So x-axis is the time. As the time increase, your height also increase. And at some point, height stops increasing. So this will be the graph of some human being of their height. This is the graph of their height with respect to time. Then a child on a swing. You know, sometimes children sits on the swing and they're like the eh? Like this. There's a seat somewhere and then there is some swing. Eh? So what happens there? What happens there? Think about it. Something like, if I can draw something, I'm sure I cannot exactly draw that, but suppose someone or something is tied here, then some children, someone is there, and then the swing started. She came here, and then again swing. She came there, and then this thing continued. She was here. Let's say, or she or he, whatever it is, whatever you like. So goes there, and then comes back here. So she's like, okay, going there. D. She will not go there. Okay, so it continues happening. So what is happening there? Basically, she starts from some constant height, which is here, then she's like, okay, she's going there, and then she's going here. She is going there and going here. If you grab that, this will look like somewhat like this. Say, this is somewhat here. Suppose you just drop her from here, then she comes down, then she goes up, then she comes down, then she goes up. So the graph will look like this. Assuming that there is no energy loss here. If there is energy loss here, then the graph will be something like, suppose it starts from like this. If there is some energy loss, then something like this. At some point it will stop. It will become straight and stop. Okay. Then this is building a house, square footage and cost. So what happens? Suppose you want to build a house. You want to make your own house. Then for the house, how the cost will increase? See, this x-axis is square footage, this axis is square footage, and y-axis is cost. It means if you try to make a bigger house, suppose let's say 100 square feet, 1000 square feet, 2000 square feet, 3000 square feet. So for 1000 square feet cost is low. For 2000 square feet your cost starts increasing. Cost is now here, cost is higher. Then if you make 3000 square feet, then your cost increases little bit more. So this is what happens in real life situation. You want something more, you have to pay something more. Yeah, so this is some kind of graph. Dropped egg. So you drop some egg from some height. Let's say you go. It's not a good idea to go to your rooftop and drop the egg. It's not a good idea. Say you go there and you drop something. Then with respect to time, what happens is this: when at time 0, when you drop it, it was at maximum height, then it starts dropping, coming down, coming down, coming down. This is not exactly the graph of throwing. Actually, some other thing also some other things is also affecting this graph. For example, if you understand physics, then acceleration due to gravity is acting on here, air resistance is acting on here, and this is the combined effect of all of this. But roughly, just if you look at it in a very natural, very simple sense, then also graph actually agrees with that. Big Mac hamburgers, this is the graph of that. Price and demand. Price is the x-axis and the demand is y-axis. So what is happening here? Suppose price is here, then the demand is here. Demand is here. That means, say price is, suppose let's say price is $1, then the demand is huge. Let's say 1 million piece per day in some city. Then if you increase the price, let's say $20 here, then the amount needed, or people the consumption of that hamburger it decreases with a great amount, you can see. That means if the price is higher, then the demand decreases. If the price is low, then the demand is high. This actually happens in our daily life also. Suppose if you look at the price of some product, whatever it is, let's say onion, uh, this suppose the price increases too much, then people starts buying it as less as possible, right? As less as possible. They think like, okay, we will not waste anything, we will just try to use our all the things that we have. Then they try to do it that way. They try to, as much as possible. People do not buy if something's price is ridiculously higher. Then people do not buy that, which is here. Price is high, then the demand is low. When the price is low, then demand is high. Of course, at the same time, the quality of the product is also important. We assume that the quality of the product is constant, then the graph will agree. So these are the graph actually. Sometimes when you study pre-calculus, then sometimes you feel like, okay, why we are studying all this thing? These are the reason actually. And some of the graphs you will see that we will study this kind of graph, and somewhat this one also. This one is quite irregular to study at this point. This one is also to some degree we have. So these are the things. Basically, all of the thing connects pre-calculus and real life. We have them actually. We have them. If you study pre-calculus better, you will understand all these graphs and more, many more, better in real life. So here we start something new for our today's lesson. This is called even function. And we have some definition and other things for the even function. Let's bring all of them here, and let me talk about what is an even function. For an even function, our definition for even function is, if you replace x by minus x, you will still get the same function. Let me write some even function for you so that it make more sense. Suppose if I write some function like fx equals to, you already actually studied even function. We talked about it to some degree, x squared. And if you replace this x by minus x, then what is the answer? Minus x whole square. Minus x whole square equal to again x square. So basically we get our question, same question. So it doesn't matter if you replace x by minus x, you still get the same thing. Any question like this is even function. Any question like this, they are even function. And for all the even function, you will see that you can actually replace the x by minus x. This is 3 and another point is minus 3. 6 is fixed. This is 2. Another corresponding point is minus 2. And actually you will understand that, you will notice that this is actually a y-axis reflection. So another characteristics of even function is they will have y-axis reflection. So all the even function, if it is even function, they will have y-axis reflection or a y-axis symmetry. Y-axis symmetry. Y-axis symmetry. So for any, you can write more even function something like fx equals to x to the power 4, x to the power 6, any even number in the power, x to the power 4, then x to the power 6, x to the power 8, anything like that. And you can actually make this even function a bit bigger kind of also. Suppose if we write x squared plus or minus something minus 3, this is also even function. You will see that if you replace x by minus x, still the question is same, question remains same, then it will be even function. For the even function, you can replace x by minus x, and if you do calculation, your answer will be again same as your question, then it is even function. But we will discuss now odd function, which will be different. Okay, let's go there. And y-axis symmetry you can see. So odd function. For odd function, what will happen is, let me write some odd function first so that you get some sense. Suppose if I write some function like fx equals to x cube, fx equals to x cube, then what happens? And if we replace now x by minus x, what happens? Minus x. Then we can give minus x whole cube. Then basically, since it is 3, then minus will be remaining there. So if you replace for some odd function, if you replace x by minus x, then you will see your function, the main element will come here, but there will be an additional minus sign before the function. Then it will be an odd function, and odd function will be symmetric with respect to origin. Symmetric with respect to origin. Odd function will be symmetric with respect to origin. And we have a little bit more detail about them. And origin reflection means what? Origin symmetry means this is minus 1 comma 3, so another point will be 1 comma minus 3. All of them will the sign of x and y both will change, then it is origin symmetry. Both will change. This is 2 comma 0, so another point will be minus 2 comma 0, because minus 0 is not possible. This is 2.5 comma 6, so this point's origin symmetry will be minus 2.5 comma minus 6, and this is here. So this is origin symmetry. Odd function will have origin symmetry. Even function have y symmetry. Odd function have origin symmetry. Now we have written a question here. This is just as a thought-provoking kind of, if you want to think about it. Can a function be symmetric with respect to x-axis? Is it possible? Why or why not? Think about it, and you can discuss it with during the class also if you want. Then we have I don't think that I should tell you the answer. Okay, think about it. This is something like, you will understand automatically a couple of things if you go through this. So now come to another important topic, which is increasing, decreasing, and constant part in a function. This is another important thing in this pre-calculus. A graph, a graph can be increasing, a graph can be decreasing, and sometimes a graph can be constant, and many times a graph can combine all of them also. Increase, graph can increase, graph can decrease, and then graph can be constant, or graph can have some combined thing. So what does it mean? What does it mean? Increasing graph means that if your x value and y value both increases at the same time, or see this portion, what happens here. Let's look at the graph and discuss it from here. Let's look at the graph and discuss it from here, so that it makes more sense. If you look at this point, what is the coordinate of this point? This is 2 comma 2 comma minus 2, 2 comma minus 2, and some point, suppose here, this is 1 2 3 4 5 6, 1 2, so it is 6 comma 2, 6 comma 6 comma 2. In fact, this part from here the graph is increasing. The trick is you will look from left side to right side. You will look from left side to right side, then automatically you will see the graph is increasing. In your regular, just simple eye estimation, you will see that the graph is increasing. And see, from this point to this point, graph is not going up or graph is not going down. Then we will say that from this point to this point, graph is constant. This point is what? Minus 2 comma minus 2. So from this point and this point, the graph is constant. Now you may say, sir, this is also increasing. It looks like it is going up. So maybe this is also increasing. Actually, this is not increasing, because always we will look from left side to right side. What happens? If you start left and then if you come right side, what happens? If you start here, then what happens? See, graph is actually going down. That means this part of the graph is decreasing actually. This part of the graph is decreasing. This part of the graph is decreasing. So this is decreasing part of the graph. This is constant part of the graph. This is increasing part of the graph. So this graph has 3 different parts. Now what about this? What is happening here? What is happening here? As I said, the trick is look at from left side to right side. What happens? If you look at from left side to right side, then you have to start from here. Then you see the graph goes up, goes up to this point. And at this point, the graph is not going up or going down. Up to this point, the graph was going up if you look from left side to right side. That means this part of the graph is increasing. And then if you always we go from left side to right side, then if you start from this point, the graph is actually decreasing up to here. So this part here is decreasing. And again, if you start from here, then the graph is increasing. So this part of the graph is increasing. Now you can say, sir, from here to here what? And from here to here what? What about that? Actually, from here to here increasing and here to here also increasing. That's why we can say that from this whole part here is increasing. Okay. So this is how we understand like what happens in the graph. Which part is increasing, which part is decreasing, which part is constant. And it is written here. increasing when x is greater than 2. So this is x, this is x, yeah, and you can see this is x is 6, here x is 4, this is 4 comma 0. That means if x value of the graph increases goes more than 2, everywhere there is increase in the graph. Everywhere there is increase in the graph, and decrease is in the this part, which is decreasing is where x is less than minus 2. This side is x is less than minus 2, and this part is decreasing graph. It looks like it is increasing. By the way, once again, I should tell you that in very normal look, if you look at this naively, if you look at this, then it will look like, okay, it is increasing. You have to look from this side, and if you look from this side, you will see that the graph is decreasing. Always from left side you look at the graph, what happens, it is decreasing. So that means if the value of the graph is less than minus 2, then the graph is decreasing. And between minus 2 and plus 2, graph is constant. Another important thing, notice here, there is no equal to sign. Because at that point, at 2, graph is not increasing or decreasing. At that point, it is not doing that. So, and see, from minus 2 to 2, the graph is constant. This part of the graph is constant. And you will see here also increasing part, there is 2 part increasing here and here, 2 part increasing, and decreasing is from here to here. So decreasing is from here minus 1 to 1, and constant, there is no constant thing here in this graph. Now you can say, sir, what is this going on? This minus 1 to 1, it is decreasing. We do not understand that. What's wrong here? Or what is this? You are not saying, suppose you can say, sir, you are not saying that the graph is increasing from 2 comma minus 2 to this side, infinity, plus infinity, minus infinity. Why you are not saying that, like, so saying this like this, saying all this thing like that? So, or you even the constant part, see, from minus 2, then yeah, this is what, minus 2, then greater than x is greater than, what is this, less than, minus 2 is less than x is less than minus 2, less than plus 2. From this part, our graph is constant. But you are not writing the points. What is this? This is not right. You are not writing this and this. Now it should be fine. You are not writing this point and this point. You can write. Can we write? You can ask me this question like, can we write minus 2 comma 2, from minus 2 comma 2 to 2 comma minus 2, graph is constant. Technically this is also correct, but the answer is, technically this is also correct, because you are saying that this point to this point graph is constant. This is actually not a mistake, but increasing, decreasing, and constant, this thing we write only the x value of the point. Okay, see, from the x value minus 2 to plus 2, the graph is constant. We only write the x value of the point for the increasing, decreasing, and constant. Yeah, we only write the x value of the point. Suppose, because I see we wanted to discuss this. This is minus 1, then 1. What is this? See, this point is minus 1 comma 1 2 3, minus 1 comma 3, minus 1 comma 3, and this point is 1 comma 1 2 3, 1 comma minus 3, 1 comma minus 3, 1 comma minus 3, and we already decided from this point to this point it is decreasing. But you see the decreasing answer is like what? Minus 1, then 1. That means we are writing only the x value of the point. Then it's enough. This is what I want to say about this. Only x value is enough. Okay, then it is enough. Then this is what? Increasing is when x is less than minus 1. So minus 1 is here. If x is less than minus 1, this part whole thing, we have our graph is increasing. Because if you look from left to right, then the graph is increasing. Then if the x is more than 1, which is this part, more than 1 is this part, If x is more than 1, then the graph is also increasing. Once again, don't get confused. You may look like it is decreasing in this side, but you have to look from left to right. Here also you are looking at left to right. Here also you are looking at left to right. This is our point. Then you go to the right side, right side, right side. See, if you go to the right side, then it is increasing. From left to right, you have to start. So we will just, the conclusion is for this writing thing, increasing, decreasing, and constant, this kind of question writing thing, you will only mention the x value of the point. From x value what to x value what, it is increasing, decreasing, or constant. And the main trick is from left to right, from left to right, or else you will keep making the mistake. Now let's look at the point. Where is maximum, minimum, this kind of thing? Where is it? If a graph is kind of this kind of curve, then you will see that there are some points. Let's bring all the line. There are some points, or without the line also we can say. Without the line also we can say. See, this graph just zigzags some kind of curve. You see that the graph, if you look from left side to right side, then yeah, the graph goes like this. Then you see there is some point up here. After this point, the graph is started going down. That means among this in this locality, in this area, this is a maximum point. Yeah, this is a maximum point, yeah, in this locality. This is a maximum point. And then you go down, 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 down. Here you see another point, which is the lowest here. Which is the lowest here. This point. Then again you go up, you go up, you go up. Then you get another this kind of point, this kind of another point where the graph actually gets some turning, and then graph starts going down again. That means this is also another maximum point. This is also another maximum point. Then again you go down, 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 and after some point the graph start again increasing. That means this is another lowest point. So in a graph we can see that there are some low point, lowest point, there are some highest point. Highest point. Lowest point we can call them, these are maximums. These points are maximums because these are some max, higher point. We can call them maximum, and we can call them minimums. We can call them minimums. This is a minimum, this is a minimum for this locality, That's why, by the way, that's why it is called local. These are local, because within this space, this is the lowest. Within this space, this is the lowest. Then within this space, within this locality, this point is highest, or this point is maximum. This point is maximum. So we call it this way. And this is the local maximum and minimum. And let me give you one more information, important information about local maximum and minimum. That is, suppose if I now ask you, where is maximum, local maximum? You will, in a second, you will tell me, sir, there is two local maximum. One is here. This point is one maximum. This point is another maximum. Okay. And this point is minimum, this point is minimum. So if I say where, you will say here and here. But how you will write it? You have to say the x value, minus 1, 2, 3, 4, minus 4. You will say that 1, this maximum is at 1, 2, 3, 4, at minus 4. You will always say that the x value, this maximum is at minus 4. Okay. If I ask you, where is this maximum? You will say that this maximum is at minus 4. And then if we ask you, what is the value at a value of your maximum at minus 4? Then you will say the y value, which is 1, 2, 3. So 3 is the value of this maximum. So the value of this maximum is 3. Let me write it here. Value of this maximum is 3. Let's write it here. This side is not clear. So value is 3 at minus 4. So this maximum is at minus 4, value is 3. This one. So the easy thing is, how can you can write the coordinate, then answer is very easy. 1 2 2 is the x value, 1 2 3 4. So this point name is 2 comma 1 2 1 2 3 4 2 comma 4. So if I ask this maximum is where, you will say this maximum is at x value, at 2. Then if I say what is the value of your maximum at 2, what is the value of your maximum? Answer is 4. Value is 4. Same thing for the minimum. Same thing for the minimum. So this is minus 1 and the minus 3. So this is minus 1 comma minus 3. So if I say what for this minimum, where is this minimum? Where is this minimum? You will say at minus 1. And if I say what is the value of your minimum, then you will say the value is minus 3. Value means y. Where means x. X. Okay, let's go to the next page. We have some. So local max and local minimum. Now see, this is from here to here, the whole graph. It looks like, since it is not a curve. Since it is not a curve. So this is the minimum. If you consider this is like this, then our graph, if I draw some curve, then you will say that, oh, this is the minimum, because in the curve you see minimum is this one, but it is not a curve, and the whole line is actually at the same point. So we can say that local minimum is from here to here. This full space is minimum, because everywhere the value is same. And local maximum, there is no local maximum here. There is no local maximum here. There is no local maximum here. Because to get some local maximum, we need something in the graph, we need something like this. So then it will be local maximum, but there is nothing like that. Now you can ask me a very tricky question. You can say, sir, what about this one and what about this one? We cannot say them local maximum, because this is arrow sign and we do not know where this arrow sign will stop. There is a problem with the arrow sign. Arrow sign means it goes forever. It goes forever. So we do not know where this arrow sign will stop, and we do not know what value we will say. So for arrow sign, just ignore the arrow sign. Do not say that, okay, this is maximum, because this is not exactly the end of the graph. The graph goes forever this way. That's why we do not have any local max, because we do not have this shape anywhere in the graph. But here definitely you have that shape, and I'm sure now you know that this is a maximum. And what is this? This is a minimum. Okay, this is a minimum. And you see local minimum, fx equals to minus 2. Fx means y equals to minus 2. That means this is the value of this minimum is minus 2. And where is it? It is at minus 2 to plus 2, from here to here. These are the x value. At means x value. Where means y value. Here also see, fx equals to 3 at x equal to minus 1. This is local max. So see, this is minus 1 and the value is 3. This is the value. This is the value. Value of this local maximum is 3, and this local maximum is at minus 1, because the coordinate of this point is minus 1 comma 3, minus 1 comma 3. So where is this local maximum? This is at minus 1. What is the value? Value is 3. Value is 3. And same thing will go for minimum. The value is this is the point is 1 comma minus 3, 1 comma minus 3. So if we ask where is it, you will say at 1. What is the value of the minimum? Minimum value is minus 3. Okay, so fx equal to minus 3, it means y equal to minus 3. Y value is the y, this y part is the value of the function. Always the value of the function comes from the y part. We have then in class practice, they are also related to this today's class. Then we have some practice homework. You do not have to submit this work, and some of the things that we want you to read. So this is from page number 80 to 84, properties of functions, a bit more. Then practice from 2.3, this maths and this maths, and they are related to the things that we discussed, even odd function, and then how to identify which one is even functions, which one is odd function. These maths are related to that. These are the practice homework review from the previous slides. You can just when you finish doing this maths, you can match your answer and check if they are right or your answer is wrong. You can check them. This math is page number 59. Then this is also from the homework review, practice homework review. This is the graph that we discussed at the beginning of today's lesson. This is the graph actually, and this is, as I said, this actually matches with one of the math from the book. This one also we said that if you for the practice this maths also, we said this is also another one for the practice maths. And if you finish practicing these maths, then you can match with this answer. This too is challenge problem. Yep, that's the end of today's pre-record. So thank you all, thank you very much. Have a good day, everyone.